All
So
right.
you just feed those numbers in. You know,
Mhm.
6 goes in for H, 4 goes in for K, 10 goes in for R.
10 goes in for R. So then, all right, yeah, I guess that makes sense because R is radius. And then, so, all right, I have one question with this.
Mhm.
So, am I making the x become x squared as well? So it's like x squared
No,
minus
no,
36.
no, no. You leave it like this.
Oh, right, yeah, then it becomes like positive 6 and positive 4.
No, no, no,
No? All right.
no, no. You leave it exactly like it is here.
Or for the what's it called?
Let me give you what I think you're, if you don't mind here. Let's say I tell you that the center of the circle is at -2, -3, and
Oh,
it has a radius of 5. X minus h squared plus y minus k squared equals r squared. It's x minus -2 squared,
mhm.
but that becomes x plus 2 squared. Maybe
X
that's
plus
what you're
two
thinking.
squared.
See how the two negatives combine into a
Oh,
positive?
I do.
Okay. Plus y minus a -3 squared, y plus 3 squared equals 5 squared.
Mm-hmm.
But no, to answer your question, no, because like kind of off to the side here, x plus 2 squared, it means x plus 2 times x plus 2.
Yeah. So, okay.
So that's x squared plus 4x plus 4.
Oh,
But no, like this is it. You're done. You're done right here.
okay. All right. Keep it simple.
Yes.
X plus squared, y plus 3 squared. It's 25. Okay.
So if we go back to your problem again, because I feel like there's still it's unclear. The midpoint gives you the center of the circle,
Uh,
and then the center of the circle is HK. So those numbers just go in for H and for
okay.
K. And because they're minus, you just leave them.
Mhm.
You can't, there's not two negatives. Now there is another variation on this question. There's the variation where they don't give you the radius and you have to calculate it.
Mhm.
But you have to tell me if you think that's something we should work on, or if we should just consider
Um,
this question as is, go on to other, number 2.
I mean, I think hmm,
It requires the distance formula.
yeah,
And that's what you were telling me for the a squared plus b squared c squared. That's kind of the distance formula, just in another form.
yeah. Um, would you be able just to scroll down just like one little bit,
Sure,
please?
sure.
Thank you. So I used that problem above to get to that part.
No, I
Where,
made this up. I made this one
oh,
up.
okay.
This is a
All
completely
right.
new
Sorry, that
problem.
was
I'm sorry. I'm
yeah.
sorry about
No,
that.
it's all good. I was just double checking. Um, because so is the first one always going to be representing like H?
The first number, and yes,
Yeah, first number, I mean.
yes, the center is h.
Okay.
The x value of the x coordinate is h.
And then I'm not squaring the radius.
You do need to square it. I mean, it does need to be 100.
Okay. So then with it being 100, that means that like every single like the circle's like 100 times out in a sense, right?
It's the
I don't know
radius
how to
out.
really
Like you go to the center and you go up 10, down 10, right 10, left 10.
Okay. All right. Okay, yeah, I think I get this.
Where do you want us to go next? Number 2, number 3? Do you want me to look at 2?
Um, I think maybe just go in order of the problems, maybe.
Okay.
Some of them.
Your work here is good for number 2.
Um, yeah, here, let me grab that paper again real quickly.
Yeah,
Yeah,
snip it in
so
here.
with question number 2, my only question with it is the domain and range part.
Okay. Now what's really helpful is you've drawn the circle.
Yeah, and I
Eh,
meant to label it even better, but I was just trying to get as much done.
It's good enough. So the domain, I'm gonna just let me actually do a shading here. So your domain, it's like going from the leftmost x to the rightmost x.
Yeah,
So it goes from 0 to 6,
0 to 6.
and that's
And
what you
then,
have here.
so did I actually write that formula correctly, like even with the number
Yeah,
placement and stuff with it?
yeah. And then the
Oh,
range, the range is vertical, so it's kind of from
uh,
top to, or it goes from bottom to top. So it's that
bottom to top
-5 to
to
that
positive.
1. I like, if I'm being really, really critical of you, I'd like to see parentheses around these.
Oh,
Like to see you label your axes. But I don't you understand. What you put in front of me, I understood. So I think this is
okay.
great.
All right, cool. Okay, I thought I did the
Now is
actual
it
formula part in the
now is
wrong.
it clear why the center's at 3 minus 2, and that
Um,
comes from this?
okay, so to be honest, I just know that the signs are switched. I
Yes.
don't know why, but I just
Well, that's good enough. Like, let me give you one example here. Let me ask you for x plus 4 squared plus y minus 3 squared equals 16. Can you tell me the center of this circle?
-4 and +3.
Okay. Yep, that's good enough.
All right.
Knowing why isn't going to help right now.
Okay, cool. All right. I'm fine with that, to be honest.
Do you ever watch Shark Tank?
Um, I guess in middle school during class, I would sometimes.
Okay. And there's another one. I don't know, there's another show. There's just really good. They're really fun business shows. Got me all excited about that. Okay. Use completing the square. Oh my gosh, completing the square. I forgot how to complete the square.
Uh-huh.
Um, so this is another form of a circle, but you wouldn't know it in this form. So that's why you have to complete the square. And what you need to do is group the x terms and then the y terms. So it's like this: x squared minus 2x. That
X
takes care
squared
of
minus
both of
2x,
those. Leave a space. Y squared plus 6y.
y squared plus 6y.
Leave a space equals, and then you're going to add that 26 to the other side of the equation.
Mhm.
And we are going to fill in the space, but
Oh, wait, that looks like the kind of problem before almost, where like the 26 could be like the radius, right?
it will transform into that. But we're gonna first focus on the x terms. Sorry about that.
Oh, good.
Okay, do you remember how to complete the square? It has to do with
Um,
that
do I
middle
just
number.
do I just multiply it by 2?
Nope. Divide by 2.
Square root
Divide
it?
by
Oh,
divide by
divide by
2.
2.
Divide by 2. This becomes x minus 1 squared. So that minus 1 is half the minus 2. Now what goes back up here? Do you remember?
Um,
It has to do with this
the
number here.
that is a positive,
You square it, so it's plus 1
+1,
plus 1.
+1. All right, and then
Actually, let me show that in a different color in case you look back at these notes, because you got to remember to share it both sides.
share both sides. Right, yeah, share both sides. So
Okay, so,
then that
so
would
what?
be y plus 3 squared, and then I'd write plus no minus
It's plus. It's plus
plus.
because
Okay, so it's always plus.
for these problems we'll say yes, but
Okay,
it's
so +9 plus 9, 36.
okay. So now it's reasonable for me to ask you, just like I did before, what's the center and what's the radius? Actually, that's what it asked: the radius and the center.
The center is +1 and -3, and the radius is 36.
Nope,
6.
it is 6.
And then I guess you can just, draw that, and then you get the domain and range. But that's not being asked,
It
I guess.
doesn't ask for that, but yeah, you could. Let's do that. Let's do that though, because this was something you were asking me about. I'll do the sketch here. So you go to your center 1 minus 3, and then you go up 6. 1, 2, 3, 4, 5, 6. You go
Mhm.
down 6. 1, 2, 3, 4, 5, 6. And you should label these points like I told you.
Yeah.
1, -3, 1, +3, 1, -9. And then you go right 6. 1, 2, 3, 4, 5, 6. So that's 7, -3, and then 1, 2, 3, 4, 5, 6. That's -5, comma, -3.
And then
So,
um
so what would your domain be?
x/xer. I know that's not the proper way to say it, but
That's okay.
it's the
Good enough.
easiest way. And then I'd write -3 is less than or equal to whatever.
Why are you choosing -3? Tell me where you're getting that from.
Because no, -5. My bad.
Yes. Where are you
Right.
getting that from?
I'm getting that from the x value from the furthest left part of the graph,
Yes.
from the negative,
Yes.
and then +7 for
Good. Good.
the highest, and then for the range, it would be same thing, line y comma -9 because that's the lowest point, and then is less than or equal to +5. It looks like
3.
3. My bad.
It's hard when it's on a screen.
Yeah.
I'm sure you do it right. Okay.
I could have counted it actually since we properly put it there, but now I know for next time.
Okay. Let's look at number 4. If that's okay. We're ready to move on.
Yeah, I'm all good.
So I mean, this is a strategy that you can use when you're studying, not just for this class, but others. But it's like if you in the previous problem found domain and range and this one didn't ask for it, you can still do it, especially when you're
Mhm.
studying. You just kind of like go in these different directions with these problems until you feel like you know the ins and outs of all of them.
Yeah, it's a good way to get a good knowledge for all of it.
Yeah. So here we go. Um, they give you these central angles. These are both central angles.
Uh,
Um, and what I mean by that is that they are from the center O, angle out. Now, the first arc to find, I believe, is probably like AB is the guy here. So it's this one here, and that exactly equals the central angle. That's good. And then they don't ask for AC, but they do ask for B to A to C,
uh-huh.
and that looks good there. That looks really good there. That's this big one. So that's really 107 plus 49. And then they asked for A to B to C. I think that's a little bit harder, but it's without this one. And
Yeah,
then A to C to B, excuse me, is without. So this last one is incorrect.
the last one is.
Yeah, let's look at that together. So it's A, C, B. So starting at A to C to B. So like, here's another way to do it.
Oh,
Which one is
360 minus 49.
yeah, and I know they don't teach this, but this is like another way to kind of do it.
Yeah,
Which one are you skipping? So
I,
yeah.
I, yeah, get rid of the 49 in that, so then that'd be, um,
Now,
311.
yeah, now minor thing, these are all degrees.
Right, that's worth writing in as well. Um,
All right, number
yeah, I don't
5.
want now that I think about it, I'm a little curious on why I thought the 253 instead.
Because because the letters, there's so many, they're just flipping the order of the letters. It's easy to just
Yeah.
think it was one you already did.
Yeah, I guess so. That must have been it.
But believe it or not, on even on college exams, they will repeat questions every once in a while, especially if they're drawn from a computer.
Huh. I'll have to keep that in mind. That's a little interesting.
Okay, so the new problem here, why didn't it seems like they're missing a like a congruence.
Yeah, I don't know. It was a little funny, and I was just like, I'm just, gonna work on my other stuff.
Yeah, now they're saying, so they're saying, maybe they didn't. So they're missing this right here. So
Mhm.
this angle, this central angle is 66 degrees.
66.
And if you go all the way around now, the blue is 360 minus 66. This is an example of a problem where you have to add in a, some lines.
Okay.
Sometimes you have to take away lines, but this one you have to add in.
And
Now,
then, is that a central angle?
yes,
Okay.
both the 66 and the blue, which is 294, is a second central angle. So the 294 is broken into 1, 2, 3, 4, 5, 6 equal pieces.
6 equal pieces.
So I believe, well, yeah, this does work. So this ends up being 49 degrees. So
Mhm.
each of these arcs is 49 degrees.
So then,
So that helps to
um,
answer, well, W is 49. That's all we can say for right now.
uh-huh. And then in order to, so I'm looking at this as a circle, correct?
Yes.
And then I know that a circle has to be 360
Yes.
degrees.
And that's how I came up with the 360 minus 66.
Okay. So then,
Now,
even if it's got like a shape inside of it like that, like I
yep.
know.
Yep. It's just a hexagon or no, it's a 7-sided. So it's a septagon um, inscribed inside a circle.
Okay. So it wouldn't be like 1080 or whatever that other, like the other way to do it, where,
No, no.
okay.
Now to find X, I had to re-establish the picture, which I know is really not like what you would be able to do. But
Uh,
if I could, I'm actually gonna make this a little smaller so that you can see that if I draw the circle with just the X like this, it's now an inscribed angle for this part.
mhm.
And that corresponds over here to 5 of the 6 that are the same.
Yeah.
So
Huh.
it's a little bit hard, but it's 5 times the 49.
That's interesting. Yeah, okay. Yeah, I guess that is just a big inscribed. And then we're looking at that one in specific just because it's labeled as X, correct?
Yes, yes,
And
yes.
then we can't do the same for Y.
We'll do something different for Y, but let's get this. So this is an X because you have to multiply. This is 245, but
Uh,
X is you have to cut it in half,
um,
if you remember.
yeah, divide in half, and then that's like one. Um,
22.5.
yeah. So then I guess that leaves us with Y. So I have a question with Y. So am I looking that as well as um what's the angle called? Like a central angle?
Yeah, like here's what you know for Y, and I mean I really have a huge advantage to be able to redraw this, but this was 49. I guess we did that in blue. Did we do it in
Oh,
blue? Yeah, we did.
yeah,
So this
blue.
was 49, which means this is 49. What kind of triangle
Oh, it's
is
a
this?
isosceles triangle,
Yeah,
correct?
so this is also Y.
And then
So it's
Y and Y plus 49 have to equal 180.
that's right.
And I'm pretty sure the Y's have to be the same, correct?
Yeah, they're the
And
same. So
then I guess the smart way to do that is the way you're doing it.
yeah, this one is really a hard problem. I mean, you have to see things that are more pattern based, and there's not math here. There's just
Yeah.
spatial recognition. I'm a very visual person, so I can
Uh, You can
I
see
can,
that.
yeah, but there's not like a math, you're not like a math ninja because you're black belt because you can do this. It's just,
Yeah, it's just the way someone is.
yeah. Okay, so flip the page and we got number 6 to look at next. Is that right?
Yes. Number 6. This one I was confused on. I'm not gonna lie.
Okay, let's see what we got here. So the only thing that was given, all right, so A is 90. That's completely correct because if your hypotenuse goes through is the diameter and it touches the other there, that's always a 90 degrees. That's really good.
So if there's like the 2 points of the triangle touching like that, then that means it's 90 degrees.
Yeah, I had this really cool thing in one of my rooms or some guy had in his office working on the place I work where it was a string that you could bend it and move it around and it always made this 90-degree angle.
Oh,
Really
that's
kind of cool.
cool.
It's really kind of cool. Yeah. So that's fine. Now you're doing great here because if I again if it, I have the experience of knowing like you should take away lines.
Uh-huh.
But if this is 70 degrees and this is C, what kind of angle is C?
Um, it is a not congruent. It's an inscribed angle.
Inscribed angle, which means it's
So half of the exterior one.
right.
It's at like 35, I'm pretty sure.
That's right. And now here's what you have. You have two of the three angles in a right triangle.
In the right triangle. So then I'd know that it just has to equal up to 180, correct?
That's right.
So then I guess 35 plus 90 would be 125, and then 35 would be, no, 55 would be needed. Wait, no, 45. 55? Wait, I'm trying to do it mentally here, but
You got it right. I mean, you had it correct here.
okay, so what I did have actually was correct.
Yes.
Huh. All right. I'm a little. Huh. Okay. I guess it's not the hardest problem. Yeah. I guess usually when I'm doing something like, wow, I don't know what this is, I'm just like, hopefully math, you can explain it pretty well. I guess I got it right. So that's
Yeah.
nice.
Yeah. I mean, and so again, like what I would tell you, if you notice, I've made three separate drawings here. Like it's really
Yeah.
good to separate it out, cut out like the B, the A, like you just focusing on the part
Yeah.
you're
One
trying
part
to
at
figure
a
out.
time. And I guess it's a pretty good way to show your work as well.
It is. Yeah. Okay. Any idea? So, okay, so there's some formulas here for the arcs on the tangents, but I don't know if we need to, maybe you don't know those yet. So this is 90 degrees. This is 90 degrees. That's how you're doing it. Okay, that's how you're doing it. And what is this shape? What is this shape here?
The shape is a kite.
So quadrilateral, we'll say, which is a
Quadrilateral.
kite. But in terms of its sides, it's got four sides. And so we know that the sum of the interior angles is n minus 2 times 180, but it's 4 minus 2 times 180, which is 360.
360.
So why does that matter? Because you know three of the four sides. You got the 90, the 90, and the 40. 90 plus 90 plus 40 plus x equals 360.
Okay. So
There is another way to do this, but you don't have these formulas yet.
yeah.
That's why I didn't.
So I guess I know that it's like 90 and 90 and 40. So then that's 220.
Mhm.
And then I know that X just has to add up along with it.
Yeah, so it looks like it's 140.
Could I? And all right. So I guess I couldn't you look at the 40 and be able to figure out the X from it. I couldn't just like say it's like an inscribed angle or anything like that.
No, it's definitely not an inscribed angle. No, you have to do this problem this way. There's not, at least for now, there's not a better way that I can show you.
All right. Yeah, I guess that makes sense for. All right. Yeah. Okay. That's not too hard of a problem, actually.
Okay, so some that you have not done yet, which at least on the sheet you sent me, we can piece these together.
Yeah, these are the ones that I was most just kind of like, I don't really know what's going on. Now that I'm looking at it again, I see that A is 90 degrees probably.
Good. That's really good.
And then I think that
Can you find, see, like I'm immediately drawn to the triangle.
yeah.
Can you find angle C of the triangle now?
You know that it has to be 180 for C, like for the total. So 90 plus 54 is 144, and then that would be 36 for C.
Okay. So this is where
Or I think
it might be,
is the 36 for angle C or CB?
sorry,
Check.
I'm in the wrong
All
spot.
good, yeah, just check.
And it's also, sorry, yeah, it's there we go. Now it's right. Yeah, I made a mistake in every lesson today. Every single one.
That's all good. That
It's
was a pretty minor one. Don't worry.
no, but I mean I make mistakes, and if you see something, say something, and because I want to make sure it's right. So what I was
Yeah.
trying to say is this is now the point where I might draw it, especially for arc AB. I can just focus on AB and realize that that's related to this angle.
Mm-hmm.
And what kind of angle is 36?
It is a inscribed angle,
Mm-hmm.
which makes it 72.
Good.
A to B 72, and then I guess you can. I guess you can say it's also an inscribed angle from C to B, correct? Maybe.
Yeah, I'm struggling here. Visually, I'm struggling with this a little bit. So,
I mean, nah, no.
oh, I see what they're looking
I
for.
was looking at it as with A as well.
So to do that one, what is the best name for AC?
Uh, the oh my God, how
It
vertex
goes through the
range?
center of the circle,
Yeah,
diameter.
diameter, right?
So that cuts the circle in half. So from A to C is 180 degrees. And you know that A to B is 72. So what do you need to finish the rest of that path?
So then, I guess it has to equal 180, correct?
That's right.
So then that would have to be 108 degrees from B to C, or C to B, I mean.
Yeah, you got it.
Huh, okay. That one, yeah, I guess once you figure out A, then the rest of it's
And
going
and
off.
again, make sure you put some degree symbols on here. I didn't do that in one of the earlier problems.
That's all good. Um,
All right, new problem here.
so then let's see. This one was just a little overwhelming because there's like two shapes, I guess, but
Yeah, let's again, like I'm gonna draw a separate picture. So here's where P is, and then like I'm drawn to
oh wait, that could be almost like an inscribed angle, right?
it is. So like this angle here is the one here. So
Mhm.
one way you look at these problems is like if I could find this thing, the blue, then I could find P.
Uh-huh.
What do I need to find the blue? Well, it'd be
And
really nice if I
then
knew the angle here. What kind
and
of
then
angle is that?
the parallel
Vertical.
vertical, and that means it's just 87 right there, correct?
Yes. And so what kind of triangle is, or what do you know about the triangle?
It'll have to equal 180 degrees total, which makes the missing angle be 29 plus 87, 16, 116, and then 180 minus 116 is 164.
hang on a second.
Wait, no, that's not right. Just
Yeah,
64.
just 64, yes. So the angle there is 64.
And then that means that P will be 128, I
That's right.
think.
That's right.
And then, I'm trying to, I guess you can look at Q also as, no, you can't look at it as an inscribed angle.
Unfortunately
Um,
not.
that would have made it easy. But
Yeah.
I guess you know that.
So R is the next one that I'm drawn to.
Mhm.
And the reason is, here again, you kind of say, oh, there's R.
Mm. Oh yeah, you're right.
So the only reason I'm able to do this is from just experience, and
Yeah.
there's no like special abilities that I have here. But if you focus on the one, like I don't know why they want you to find Q next, because really R is the next one to find in this problem.
Yeah. But yeah, I guess I mean Q is just inscribed 58.
Yes.
Huh, yeah. You really gotta look at those in a unique way. Yeah, so then I guess
I'm just waiting for my screen's slightly lagging here.
oh, it's all good.
There it is. All right. Now there is something very special about S and Q. You have any idea what's special about them?
Um
It has to do with these little
they look
congruences.
like they're the wait a second. I guess they're the same length.
They're congruent, yeah.
Um
You might be like, well, how does that help me?
yeah, I'm
Well,
just trying to
if we
see
break
the
up the circle into, again, where we have some numbers, it's like, all right, this was 128. This is 58.
then
This
I
is
guess
X and this is X.
just add those together and
Yes.
subtract 360 by it. So then that would be one is it you're right, 58 plus 128, that's 190.
Try again.
No, wait, no, that is definitely not 190. That's 186
Yes.
total minus 360. 360 minus 180. I'm actually gonna write that one out. 360 minus 186. That's 274 divided by 2. 1, 3. 137.
Did you wait a second?
Wait.
It's 186, and then you subtract that from 360.
uh
So that's 174,
174.
but you have to divide that by 2.
And then oh, I wrote that wrong. I wrote 274 instead of 174, which makes it 137. No. What am I doing wrong here? No. 8
Should be like 87.
Yeah, 87.
And there is some relationship to that. I don't really remember what that is, but we can. I think it's because these two are the same, that those are the
Yeah.
same. But that's another theorem thing you'll get later. All right, so on to number 10.
Yeah. On to number 10. This one was I did that one with a teacher because I had no idea really.
All right, so this is the finding the area of the pizza slice. The pizza slice. So they don't give you this formula in the book, but we're gonna work it out here. What is the area of a circle? They do give you this one.
They give you 50, and that's a
No, I'm asking you, what is the area of a circle? What's the formula for that?
sorry, 360.
Nope, that's the number of degrees in a circle. We will use that in a moment.
Area of a circle, like just any circle, or this one?
Yes.
I guess.
Pi r squared.
Okay.
Okay,
area.
now I'm gonna give you the another formula here. So this is also the area of a circle, but it includes this 360. So if you go all the way around, like if you have a circle and you go all the way around, your x is 360. And you can see that 360 over 360 cancels out here.
360 over 360.
And
That's
you just get pi
true.
r squared. So
Yeah.
so this is really the area of a sector.
Area of a sector.
It's the angle out of 360. You can just write that. You can just say angle over 360 pi r squared.
Pi r squared.
Okay, so in this problem, what is the central angle here? What is the angle that they're giving you?
50 degrees.
50 degrees. Okay, so it's 50 over 360. What is the radius of your circle?
The radius of my circle is 360 degrees.
Nope, radius. Distance from the center.
Oh, sorry. 50.
Try again.
100.
Okay, what is this number right here?
12. Oh my
Okay.
God, sorry. I don't know what I was doing there.
You do sound tired. I know we end up being on the later end with these lessons, but
Yeah.
if you need something earlier, just let me know in advance to try to get you in. So this is it. I mean, this is your answer.
Oh,
Okay, but this is the unsimplified exact answer.
unsimplified exact answer.
Yeah. So which means that you probably get partial credit as is. It's also missing units, which we'll get to. So do you remember how to reduce these fractions here?
You just get rid of the 0.
Right.
And then 5 over 36 times 36 or pi 36, and
Right.
then
So you can actually cancel those.
and then you just have 5 pi, and that would be your exact.
With the units feet squared.
Yeah, and then if you wanted to get approximate, you'd multiply it by pi, I'm pretty sure.
By 3.14 or whatever approximation you're using. Yes.
And then that'd give you like 15 point whatever.
Yes.
And then
So let me give you another problem like this, a more simpler problem, but it's a pizza slice problem. Let's say this is 30 degrees. The radius is 3
radius is 3.
inches, and we want the area of the pizza slice.
Mm-hmm.
So the area of the sector, the pizza slice, is the angle out of 360 pi r squared.
Pi r squared. So then angle over 360 pi r squared.
So
And
what is the
then
angle in this case? What's the central angle?
30 would be the angle. And then you can just get rid of the zeros for it, and that would be 1 over 12 pi.
Anything
And then,
else?
r squared.
What's the radius?
Radius is 3. No, 6.
The diameter is
Sorry.
6.
Diameter 6, radius 3, sorry. And then that would be 9. And then I guess that would be 3/4 pi
3/4 pi inches squared.
squared, and then 3/4, and then 3/4 and times 3.14. I'm just gonna use a calculator for that because that's
You don't have to. It's good enough as is. We should move on to the last question. Make sure we get 11 in.
And then this one. Okay, this one was like a little weird because I understood that the
So you really want to draw the large circle and then the small circle. Now, what's the radius of the small circle?
3. centimeters.
Okay, what's the radius of the large circle?
4 centimeters.
Nope. So
Radius of the large is 7, my bad.
it's 3 plus the 4, which is the 7. That's why it's so important to draw these things out, draw them out. They're all deceptive, they're all like, we're going to make them a little harder than they need to be. So you find the area of the large and subtract the area of the small. Now, before I work through this, I worked with a guy, a very smart man, and he told me, he said, Matthew, I'm going to give you some advice. He says the healthiest part of the donut is the center. And he was referring to this part that does not exist.
Yeah.
So it was a joke. I mean, it was sort of funny.
Yeah.
Anyway, the area is pi r squared. So I'm going to use big R for the large radius, and little r for the small radius. So it's pi 7 squared minus pi 3 squared. 49 pi minus 9 pi is 40 pi.
5. Oh, my bad. Sorry, I don't know why I said 5 for that. Yeah, 40 pi.
You need units, centimeters
squared. And then that's your exact, and then your approximate
exact.
would be 120 point whatever.
Yes.
And then, okay. Yeah, these aren't actually really too tricky once you kind of use like math knowledge for it.
Right. So sometimes you see a problem like this. I'll give you, actually, let me redraw it here. They give you this, and this. So they give you 3. And they say, oh, that's 1, and that's 1, and that's 1. And they want like the area of, this one maybe. So you just don't get distracted. Draw the actual circles. And there's a big, I didn't quite get. You draw the 3 that you see. Be like, oh, the little one is 1, the next one is 2, and the last one is 3.
And then 3, 2, 1.
Yeah, and we don't have time to go through that, but I just wanted you to see that you really do need to